Equation of motion. So a body starts moving from rest with a constant acceleration, covers displacement s1 in first p minus 1 second and s2 in first p seconds. The displacement s1 plus s2 will be made in what time? Okay, right. So we have given that the displacement s1. So here I'm going to use which formula? Because time is given and the displacement is given, we can assume that the constant acceleration is a and the initial velocity is 0. So let us use s is equals to ut plus half at square. So I'm going to apply this formula 3 times. First for s1, then for s2, and then for s1 plus s2. So s1 and initial velocity is 0 plus half a p minus 1 square, and then s2 is equals to 0 plus half a p square, and then s1 plus s2 equals to 0 plus half a, let us take the time as t, and we have to find t square. Now from these two equations, right, so we can add these two equations. So we can say s1 plus s2 will be half a times p minus 1 square plus p square, right? So if we compare, now let us compare this equation with this equation. So we can clearly see that t square is equals to p minus 1 square plus p square, and this will be 2p square minus 2p plus 1. So we can clearly see that option 2 is the right answer. Now let us see the next illustration. A small toy starts moving from the position of rest. So initial velocity is 0. Under a constant acceleration, let us say a is the acceleration. If it travels a distance of 10 meters in t seconds, the distance traveled by the toy in the next t seconds.
So before I start solving this, if you're preparing for JEE or NEET and you feel stuck with concepts, strategy, revision planning, or question solving approaches, then you can check out Pracbee. At Pracbee, students can book personalized one-to-one mentorship sessions with experienced mentors to get individual guidance based on their own strengths and weaknesses. Now with that said, let's get into the question and see the smartest way to solve it.
Okay, right. So let us the toy covers a distance a to b in t seconds, and it covers the distance a to c in 2t seconds, right? A to c. So what we're going to do, we'll apply equations of motion between a to b and from a to c, because it is always convenient if one of the state of the particle is at rest. So from a to b, we can say we have to find the distance traveled by the toy in the next t seconds. So we can say from a to b, ab is half a t square, and t square is t square, and from a to c it will be half a 2t square. So that will comes out to be 4 times half a t square. Now what is half a t square? That is nothing but 10. So that is 10 meters. So it will be 40 meters. So the distance covered by the particle from b to c will be 30 meters. So can you see when the particle is released, or you can say when the particle is released from rest and it is moving with a constant acceleration, then the displacement in successive equal time interval will be in odd ratio. So it will be 1:3:5 like this. So in first t second it has covered a displacement 10. So in the next t second it will cover 30. In the next t second it will cover 50. So like this you can remember also. This is also known as a Galileo's law of odd number. Now let us see this question. A particle is moving in a straight line such that its velocity is increasing at 5 meters per second per meter. So we can say dv by dx is given as 5, right? 5 meters per second per meter. The acceleration of particle is, so we have to find the acceleration of particle at the point where the velocity is 20 meters per second, right? So let us try to do this. So dv is given as 5 times dx. Now if we divide both sides with dt, this is nothing but the acceleration and this is nothing but the velocity. So we can say acceleration is 5 times the velocity, and when the velocity is 20, acceleration will be 100. So 100 is the answer, right? Right. So now this question is not from this particular type, right? Because we haven't used any equation of motion, but still remember like what we have done. So what we have given in the question, accordingly you have to solve the question. An engine of a train moving with uniform acceleration passes the signal post with velocity u and the last compartment with the velocity v. So what we have given, there is a train. This is the front end and this is the rear end. And let us say this is the signal post, right? That is the signal post. So it is going in the right direction. At this very instant, the velocity is u. And when the rear end crosses the signal post, so when the rear end crosses the signal post, at that instant, the velocity will become v. So we have to find the velocity with which the middle point of the train passes the signal post. Something like this. When the middle passes the signal post, we have to find this velocity. Let us call this as v prime. So I'm calling these three instants. Let us say the first instant is t1, and the second instant when the middle crosses the signal post is t2, and when the rear crosses the signal post, that instant is t3. So let us apply equation of motion between t1 and t2, right? And then we can apply between t2 and t3, and we'll try to simplify the equations. So let us see. So if we apply between, say, t1, let us apply between t1 and t3, right? So we can use this relation. So v square is equals to u square plus 2as. Now here displacement is nothing but the length of the train. So let me take the length of the train as L. Now if we apply the same equation of motion between t2 and t3, in that case the displacement of the train is L by 2. So we can say it will be v square is equals to v prime square plus 2a L by 2. Right? Now what we have to do, we have to eliminate AL. Okay, so what we're going to do, let us multiply this equation with 2, and now we can subtract. So let us subtract these two equations. So we'll get minus v square is equals to u square minus 2v prime square plus 0. So v prime square is equals to u square plus v square by 2. So v prime is root of this, right? U square plus v square by 2. So option 1 is the right answer.